The entity describes the interface of our design. Now, how can we describe the behavior of our entity? What the entity does? The architecture statement describes the underlying functionality of the entity. Architecture is always related to an entity and describes the behavior of that entity. For instance, the entity N2 is described by the architecture named N2_A. The entity N2 that represents this port is described by the architecture named N2_A. A single entity shall have at least one architecture. It is possible to have more than one architecture for the same entity. For instance, N2 entity in this case have the behave N2 architecture, in which is described the behavior of N2 in a behavioral way. The output C take the value of A and B after an amount of time of 3 nanoseconds. Of course, this type of code cannot be implemented in hardware device. It is used only for test bench purpose. In fact, the delay cannot be mapped in a real hardware using the clause after. The delay is dependent only by hardware implementation of the logic and will be computed only after the layout. These statements will be clear in the lab section. In the other architecture, struct_N2, it is present the instance of a component, loot_N2. Now, we are introducing the concept of component instantiation. In this example, loot_N2 is a primitive component of our device. Now, let's see few golden rules for entity architecture pair implementation. It is not mandatory to follow these simple rules, but they are good design rules generally followed by the hardware designers. The first one is to use only one architecture per entity. As seen before, you can use more than one architecture per entity, but doing this, the vhdl code could be difficult to understand. Write the architecture description code in the same file where you write the entity definition. Use one file per entity architecture pair. Use the same name for both entity and file. For instance, if the entity name is N2, the file name should be n2.vhd.